Well, let's switch over to your textbook now. And you don't have to, you can certainly follow along if you'd like. If not, I'm going to go through some example problems they have in the chapter. And then we'll take a look at some problems that we can do for practice a little bit later on. They are setting up a situation where they want you to use equations to solve problems. So, and in particular, they're talking about linear equations. And linear equations are going to be equations that have x in it to the first power. So as opposed to x squared or x cubed, these are higher order values of x. X squared, that would represent quadratic equations and cubic equations. But if we have x to the first power, we are typically, well, we're always talking about sort of linear equations. And the thing with solving equations from word problems is you have to read the problems and try to understand how to put English sentences into mathematical sentences. And I'm looking at example 1 on page 54. And as again, as I said, you're welcome to follow along here. And the thing I like about this is it also asks you to represent x, or use x to represent a value in thousands. And that's one of the things about variables. You can specify the magnitude of them. So it says here, they show you a graph on page 65, which shows pay of male and female with this supposed pay gap that they've been pushing for years here. And they're showing that you have a high school degree, high school dropout, high school degree, some college, an associate's degree, bachelor's degree, and master's degree. And they show you in thousands of dollars on the y-axis the average salary. So it looks like the gentleman there with the some high school, and again, this is so, I hate these graphics here because they show the poor guy with a mop, and you know, he could have started a business to be making billions of dollars, you know, but let's just play along with their little diagram here. They say he's making $25,000, some high school grad $38,000, some college $41,000, and then they go up in there, up from there. And so let's read the question here. It says the average salary of a man with a bachelor's degree exceeds that of a man with an associate's degree by $25,000. The average salary of a man with a master's degree exceeds the man with an associate's degree by $45,000. Combined, the three men with each of these degrees earns $214,000. Find the average yearly salary of men with these levels of education. Well, the easiest thing to do with something like this is just let x be the most basic of all of these things. That would be the fellow with the associate's degree. Okay, since this person, they say that was the lowest degree illustrated here. And then it says a man with a bachelor's degree exceeds that of a man with an associate's degree by $25,000. So this is the guy with the associate's degree, and then the guy with the bachelor's degree says, I make $25,000 more than you. And again, X is going to be represented in thousands. And then they come along with the person with the master's degree, and the master's degree says, I beat you by $45,000. So that's your associate salary plus $45,000. Oh wait, just 45, because we're reporting these things in terms of thousands already. And together they earn $214,000. And at the end of the day, when you get X, you'll have to report it in thousands. So when you do this, you collect your like terms, and you've got 3x, x plus x plus x, plus 70, right? Because what we have here is 25 plus 45, and that equals 214. So when we go ahead, we're going to solve that for x. Very simple equation here. But this is how we turn the words into a mathematical sentence. We're going to subtract 70 from both sides, and we're going to say 3x is equal to 144. So x is going to be equal to 48. So looks like the associates guy is going to make 48,000, and you're going to add 25 to that to get the guy with the bachelor's degree. And right, we're going to add, what did I say to that? 25, 5 and 3, 13, 70, what is it, 73,000? And then we would add 45 to the 48. And don't add it to 73, because you're going to be wrong then. So if you do 45 plus 48, you're going to get $93,000. And again, you know, this is, who knows what this data is based upon. So that's how you would read that. X is the amount that the associates guy makes. X plus 25,000 is the amount the bachelor's guy makes, and X plus 45,000 is what the master's person makes. So that's about that. If you take a look at question number 2, and that's on page 56, what they're doing is they're saying, hey, researchers have surveyed college freshmen every year since 1969. So they took a bunch of dirty hippies in 1969 and asked them questions. And they said, okay, in 1969, 42% of students said being well off financially was important, and 85% said developing a meaningful philosophy of life was important. And in 2013, 82% said being well off financially was important, and developing a meaningful philosophy of life was only 45%. And that data is available off of that bar graph on page 56. So it says, for the period from 1969 through 2013, this percentage increased by 0.9 each year. If this trend continues, by which year will all college freshmen consider being well off financially, essentially, or very important? Well, they give you the base conditions. They're starting in 1969. They said starting in 1969, 42% of the dirty hippies, well, they weren't the dirty hippies, they were the ones actually studying. They said being well off financially is going to be good, and that amount increases by 0.9 each year. I can call that T for time, or you can call it X. It doesn't matter what you call it. And they want to know when all of these people are going to give up their unrealistic dreams of a meaningful life to earn money. So you want this all to add up to 100%. So when you do that, you come up with a very easy equation. So this would be kind of like your, if I was going to write this as an equation, this would be like the slope of the line. So if I was going to put this in standard form, y is equal to mx plus b, well then we would say y would be equal to 0.9 plus 42. That would be sort of a linear equation. We could plot that and then see where this y value is 100, and then, oh, I have to put a t there, and we would definitely see some graph that looks like this, where this was 42 and this was time here, excuse me, this was time and this was percentages. So anyway, going ahead and looking at this, once again, no big trick to it. 100 minus 42, okay, that's going to be 58, and we are going to go ahead then and divide that by 0.9, so 0.9t is equal to 58. So t, the time it takes, is 58 divided by 0.9. And so when I go ahead and do that, I end up getting a value of 58 divided by 0.9, what, somewhere around 63 64. So the time is 64. Excuse me, I got to take the phone call. That, and of course, on that unit, you would want to have years, and that would be years after 1969. So 64 years from 1969, and everyone's going to care about money and not having a meaningful life. And that's good. So the rest of this section, oh, this is a good one. Let's take a look at example 3, because this shows you how we have two linear equations, and we need to figure out where they intersect. A lot of times you're going to be given a way to come up with two equations, linear equations, and you want to find out where they're equal. And let's say, for example, we could go back to our percent versus time, and maybe we have two different surveys, and one shows a graph something like this, and one shows a graph something like that, and you want to find out the time where both of these things are equal. Well, you'd have to basically set the two equations equal to each other and solve for that point. That's an example of this next one on page 58. Page 58 says, the toll to a bridge costs $7. Commuters who use the bridge frequently have the option of purchasing a monthly discount pass for $30, with the toll being reduced to $4 a trip. How many bridge crossings per month will the total monthly cost without the discount pass be the same as the total monthly cost with the discount pass? Well, without the discount pass, your cost is just $7 each time you cross the bridge. And that's going to be equal to, well, you had to pay $30 for the bridge, for the Instapass, or whatever you want to call it, plus 4x. Now we could have used t there for time, doesn't matter. So you have two equations, or two linear equations. One if you don't have the Easy Pass, and one if you have the Easy Pass. You set them equal to each other, and go ahead and solve. They're very easy. Subtract 4x from both sides, so you get 3x equals 30. So the break-even point is if you make 10 trips across the bridge. Now, if you're not going to make 10 trips across the bridge, well, you're not better off buying the Easy Pass or the Bridge Pass. So you can figure those types of things out. So these are using linear equations, and as I said, I will be posting some homework problems for you to look at. Pages 62 and 63 and 64 are very much what I just talked about in the first video. I will suggest the following in case you need to go back and review them. That on page 60 you have all sorts of geometric formulas for area, perimeter, and volume that you're probably going to need to know for some homework. Okay, so this is the second video. The last one will be on the last section of the chapter. I'm going to get through all of chapter 1 tonight and make sure that you are familiar with the different concepts. So we'll be back with more in just a little bit.